To find the pH of the salt sodium cyanide, let's first determine the parent acid and base that produce this salt. Sodium cyanide comes from the reaction of HCN and sodium hydroxide, which produces the sodium cyanide and water. HCN is a weak acid, and sodium hydroxide is a strong base. Now let's take a look further at the products. Sodium cyanide will dissociate 100% to form sodium ions and cyanide ions. Water will self-ionize to produce hydronium ions and hydroxide ions. Looking at the ions that are produced by the salt, Na+ is the ion that comes from a strong base and won't react any further. However, cyanide is the conjugate base of a weak acid and can react with water, and it will react with the hydronium ions. Using up the hydronium ions will force the reaction to the right, and an excess of OH- ions will be present, which makes this salt basic. Cyanide will undergo a hydrolysis reaction, which is the reaction with water, to reform HCN and our OH- ions. Since Cn- is a base, we're going to need the expression for Kb, which will be equal to the concentration of HCN times the concentration of OH- over the concentration of Cn-. In the problem, we're given the Ka for HCN, and so in order to find the Kb for its conjugate base, we use the expression Kw equal to Ka times Kb. Kw is the ion product of water, which is 1.0 times 10 to the minus 14, and we divide by the Ka, 4.0 times 10 to the minus 10, and that will give us our Kb, 2.5 times 10 to the minus 5. Now we're ready to set up our ice chart. The initial concentration of Cn- is 0.25 molar. That comes from the dissociation of the sodium cyanide. We have no ions. Our change is minus x plus x and plus x because the reaction proceeds forward. And our equilibrium concentrations are I plus C. Let's solve for x using the Kb. 2.5 times 10 to the minus 5 equals x squared over 0.25 minus x. Once again, we'll assume that x is much less than 0.25, so we can ignore x in the denominator, making the equation 2.5 times 10 to the minus 5 equals x squared over 0.25. Multiply both sides by 0.25 and take the square root, and we get x equals 2.5 times 10 to the minus 3. X is the concentration of OH-, and so we first need to find the POH by taking the negative log of 2.5 times 10 to the minus 3. Our POH is 2.60. To find the pH, we subtract our POH from 14 and end up with pH equals 11.40.